You can see what we're going to be up against here. This is one of the most convoluted, frankly idiotic chassis designs I think I've ever laid eyes on. Hey, what's up, dudes and dudettes? Brad the Guitologist here. In today's video, we are going to open this box, pull out what's inside, and troubleshoot it. It's got some issues. Customer sent it to us, and we'll see what it is. Stick around. We have a letter. It says, Brad, I'm honored you're working on my amp. This can just be a fix and ship it back with only a few things I'd like done to it. I'd like the reverb a bit wetter and juicier. I'm not sure I'm going to be able to do that because the reverb's in this. If this amp is what I think it is, I'm pretty sure it is. I don't know what I'm going to be able to do to modify the reverb. I should have probably said that up front. The reverb is not made in this amp like it is on the amps you're used to seeing me work on. I'll do what I can, but I can't guarantee that I'll be able to modify it to make it wetter. And an 8 and 16 ohm switch installed with the speaker jack moved to a more accessible place. Well, I mean, again, if I can do that, I'll do it, but if there's no tap on the output for 8 or 16 ohms, I can't remember whether this amp has it or not, just off the top of my head. If it's possible, I'll do it. If it's not, though, I'll let you know. Yeah, we'll look at this. Maybe if there's ways I can improve it, I'll do my best to improve it. As far as the 8 and 16 ohm switch that you want, I don't know if that's going to be possible. Okay, so he's got a couple of paintings here. What? This is like maybe acrylic on board, poster board. It's really cool though. I like it. Okay, so now finally we're down to the amp. Let's get this thing out of here. See what it is. It said you've already had some clues. Oh, here's some more paintings. It's pretty cool. I love that crackle. It's actually pretty badass. This actually smells like it might be spray paint. Anyway, here is the amp. Let's get it out of the remaining packaging. It's not in its stock cabinet. Peavey Classic 30. And like I said, it's in a cut down cabinet. Been modded basically. Nothing on the front. He needs a big old vintage Peavey logo for that front. That'd be cool. But yeah, these can be good amps, these little Classic 30s. I've never had one on the channel before, but this will be a first. But yeah, let's go ahead and get this up on a cabinet over here. So we'll just go ahead and set it up over here and see what it's doing. He said the reverb is out on it, so we're gonna just confirm that and go from there. Okay, I'm gonna put the old tubes back in it just for the time being. The reverb on this is run off of an IC, probably, if it's like the one I had. What I had was the Classic 50, not the Classic 30. I had a Peavey Classic 50. I have not looked at the schematic for this yet, but that one was run off, and I love the sound of that thing. It was killer. But it was run off of an IC for the reverb, which sounded fantastic when it worked. But every now and then, for whatever reason, it would blow that IC, and you would have to order a new one. And I mean, it would work fine for a little while, and then it would blow again. Could be a repeat of that sort of issue. But like I said, I'm just putting the old tubes back in. He did not indicate that they were causing any major problems, like you know, blowing fuses or anything. So that's not part of the complaint. So I don't see any reason we can't at least see if we can recreate the problem with these old tubes. Now, if he had said something like, you know, hey, it's blowing fuses and this and that, there's no way I'd do this like this. His only real complaint of malfunction was that reverb. Okay, this is a completely mismatched pair of output tubes. Man, it's like a 30-minute job to unpack this thing. Let me see. Is this... This is probably the internal speaker jack, right? This is probably the speaker jack. I guess he wants this moved to the back panel. Let's plug her in. Okay, we got filament in one output tube, three output tubes. I'm not sure about this fourth one. I can't really see any filament. Yeah, it's got filament. Just took a minute to glow. That's a really microphonic tube, so good thing he's changing that. No, wait a minute. That's that tongue sole he wants to keep. That's microphonic as hell, or either that or they've got the, okay, treble is all the way up. That's maybe one reason why. All right, reverb. Now, I can't remember on this one either. Does the reverb have to have the switch? And the remote switch has a dual function. It does the boost and the reverb, I believe. Now, correct me if I'm wrong. And there's a channel switch. It might have 3 buttons for this model. I can't remember, but there is a foot switch. He didn't send it, so it makes me wonder if he even has the foot switch, and maybe that's the reason why it didn't work. Probably ought to get a schematic. What do you reckon? Getting a schematic would make some measure of sense, would it not? We will do that soon. Hang on. I just want to stick a guitar onto it for a second. It's taking a whack over here. Thought I just heard reverb. No, maybe not. I want to find a switch. I don't have one handy. Let me dig around for a switch, because I cannot remember if you have to have the switch to work this reverb. The reverb's doing something. The circuit is adding noise, so there's definitely something coming out of the tank. Okay, this is going to look like a really silly way of doing this, but it does work. But I've just got a cable plugged into the foot switch. I'm just using this slide to complete the circuit from the tip to the sleeve here. Yeah, I know, right? There you go. Hear it? Hear the difference between, because the reverb's all the way to 12. So right there it's off, and here it's on. So that is turning the reverb on and off. I'm wondering if it ever worked at any point since being put in this cabinet. Because sometimes people hook the tanks up backwards. Tell you what, we have to change, like I said, we got to change tubes and everything anyway, so let's just go ahead and get it up on the bench, and we'll check it out inside, look at the schematic, see if there's anything we can do about moving that jack up here to the panel. There may not be room up here on the panel to move that jack up here. All right, so here we are on the bench with this thing now, and you can see what we're going to be up against here. This is one of the most convoluted, frankly idiotic chassis designs I think I've ever laid eyes on. I knew these Peaveys were kind of weird like this, but I had forgotten that they were this weird. So what you've got here, check this out. So you've got, no, don't worry about it. Nothing to worry about there. So what you've got here is a chassis that has basically 3 main boards in it. You've got this top board right here, you've got this back board here, and then you've got a bottom board which serves as the board for the tube sockets down here on the bottom, and they are curved around like in a horseshoe shape. See the pots in there, how they're soldered to the board. So when you get this out, you've got to flex this whole thing. This whole top piece has to flex downward once you get all this stuff loosened up here. This top will flex downward and everything will kind of collapse together and then hopefully come out the back here. Stuff coming from the reverb right here. It's coming up through this hole right to here. So that gives us a clue, hopefully the proximity of the reverb. There it is. There's that reverb IC right there. So this is your reverb control. The reverb send and return is right here, plugs in, and there's that IC for the reverb right there. Luckily it's socketed, so it's not difficult to replace, but in all likelihood it does need to be replaced. That was the problem that I had with my Peavey Classic 50, which was one of the tweed style Classic 50s, and I think it was probably made in the mid 90s, the one that I had. But yeah, it blew, I don't know, probably a couple of different ICs in the time that I had it. I might actually, we might get lucky. I might have that IC on hand. I'll have to pull it out and see what it is. Look at the rest of this. So we've got all these Illinois capacitors, you know, and these are older Illinois capacitors too, man. So that's, you know, Illinois capacitors really aren't great from this period. There were lots of instances where these capacitors just did not hold up. So it's probably worth it to go ahead and replace all of these. I don't want to get the orientation of this backwards, so we've got the little circle mark that was facing the back of the amp, so we'll just have to remember that. So Texas Instruments, what is it? Is that what that says? RC4558P, I'm thinking. That's the IC that we need, probably, to get the reverb going. That's my guess. But you know, there's a lot more in here that could be done. He was like, he seemed to be okay if I just rewired this into a hand-wired amp. The problem with that is I could do that, but I mean, look at the transformers. The output transformer's not that bad. It's, you know, it's got a little bit of heft to it. Power transformer, you know, it's kind of puny, but you could probably find a better set of transformers in some older piece of equipment and put your time and effort into that. You know what I mean? I just don't think rebuilding this thing as a hand-wired amp would be worth the time or money. But we'll go ahead and take all of the controls off here. There are also some screws on the bottom down there where the tubes are. We will have to take those screws out. I'll show you those in a minute, but let's just go ahead and get all this stuff off first. Yeah, these are a good sounding little amplifier. You know, they got some really nice tones, you know, really nice classic tones, really Britishy, very Vox-ish. They just sound great, you know, really good lead tones. But on the flip side, you've got to put up with really construction like this. You know, this is not, if you're okay with the construction methods, then it's a decent amp. But otherwise, yeah, I would say these generally would be a pass for me. Okay, so yellow goes toward the back side and red goes toward the front side. Are these gonna be, all right, well, blue and yellow go back here, and then we've got green and white right here in the middle, and then my three wires go here. That one will be self-explanatory for sure. These are some diminutive little pots, man. The nuts for these pots are just tiny. That's most of that stuff. Now we've got these. And this is on actually a separate little tiny board, I think, with a ribbon cable. Almost there. We just got to get, yeah, see these stupid clips, just they fall off whenever they feel like it. I'm just going to get rid of them. Just in the way at this point. I think I might have dropped one a second ago. I'll find it in a minute. No, there it is. Got several screws here, and they're really small. This is not the fun sort of stuff you want to work on. At least it is still serviceable. You know, all the components are through-hole components, and the one IC that I know of that was in here is just for the reverb, and It's pretty easy to change. It's socketed, you know, so it's not the end of the world. It's really, at the end of the day, it's a small complaint, but it is still a bit of a pain in the ass. So let's move those back and these up through there. Okay, like I said, this whole board, this whole thing flexes. So this pulls out and comes out, and then this little ribbon cable has to get out of the way so that this will push downward, flex downward, and then this bottom part should flex up slightly. So basically they've got to come together and then slide out the back. It's not as bad maybe as I was making it out, but it's just still, you know what I mean? Why am I taking this whole damn thing apart? You feel me? It's just stupid. Just stupid. See? Here's the whole amp right there. I mean, on the bright side, if there is a bright side, that's the whole amp. You know, pretty much everything's out of here. So if you did want to make this into a hand-wired thing, you could. You know, it would be a bit of a pain in the ass just because of the way that this is all oriented. You know, it's just in a really hard to get to way, because you would have to put the sockets, you'd have to mount the sockets and wire everything, and you know, imagine wiring the pots for all this stuff. Everything would have to face outward this way, but still getting up in there with your soldering iron, you'd have to come from the side, you know, or come at a real low angle to solder everything on. It would just really be kind of a pain in the butt to even convert this. It's doable, but not by me. It's not, I would have to charge so much. This guy would not want to pay that, you know, to have a hand. Oh, you've got a hand-wired Peavey Classic, but, you know, how much did you have to pay for it? Well, probably a lot. Here is the chassis. We do have some transistors in addition to the IC. You really do need to flex this to replace this stuff, because you got to get to it. You know what I mean? It's you really do. You got to flex at least this part right here, and if you do that 2 or 3 times, you know, you're weakening all these little connections right here. I'm probably going to get with him and see what he wants to do about these capacitors. I mean, I would have to order. I don't think I have this 2200, but these Illinois capacitors, they have such a poor reputation, especially the ones from this era. These have actually held up. I mean, surprisingly enough, none of them are bulged that I can see. So these are still kicking, but for how much longer, who knows? Like I said, we do have a couple of transistors. We've got one here and we've got one here. This one, that's going to the reverb, so that's probably in the reverb circuit also, that little transistor. And we've got another transistor over here. And there's that one that I think is in the reverb, because this leg right here is going right here to this pot. That's the reverb pot. Of course, it could be ground, I guess, also. So I'd say all of this, that, these two resistors, this IC, this is all reverb circuit stuff. Looks like it splits off over here, and some of this is also definitely part of the reverb circuit. This stuff is part of the reverb circuit. We're splitting off over here. Maybe some of this is involved too. Remember, I made it a point to say which one was the yellow and which one was the red wires. Over here, when I took those connectors off, well, they're marked Y and R. This one has 3, but they're a different configuration. So yeah, you can't mix those up. Let's go ahead and grab a schematic, and we'll have a little bit better idea what we're looking at here. Okay, so what we definitely want to do is replace all these capacitors. Also, the screen resistors, there are 2 100 ohm screen resistors, and this is a very weird setup that they have. I'll show you on the schematic here, the screen resistors. Yeah, so the screen supply from the power supply comes in here and comes up this line, Y's off. You have one 100 ohm resistor here at 5 watts for this screen on this tube, but then over here on this tube there's no screen resistor at all. On this one there's no screen resistor at all, And then over here on this side, there's another 100 ohm 5 watt into this tube, which is just weird, silly setup. So what we want to do probably is move this screen resistor to a point back over here somewhere, basically where it wires off and supply and feeds 2 of these tubes. And instead of a 100 ohm, we'll do like a 1K or 470 or something like that, something a little bit more traditional. And then the other Y will go to these other 2 tubes, or vice versa, however we want to do it. But we want to do it really in such a way that we at least have screen resistance on all of those tubes. But we're gonna first go ahead and pull these capacitors off here, because I'm not really sure what value these are, and I'm at least gonna have to order these because I don't stock 2200 microfarad at 50 volts, so I'm gonna have to order those. And as always, we want to take note of the orientation. We've got the negative ends over here on these. Okay. Yeah, 22 microfarad at 450 volts. Okay, positive end is up this way on this one. We're also going to have to come on here with a heat gun and remove all of this adhesive that they've got going on here. This is just really kind of over the top the way they've done this adhesive, but I guess it did prevent them from coming off or rattling. But it's a real mess on here too. We're gonna have to remove all of this crap. The other thing about this kind of stuff, adhesive like this, is sometimes it can kind of absorb moisture and sort of crystallize and become conductive in itself. We've got a bunch of it over here too, and underneath this one. All this will have to be done. So there's all those off the boards. We'll go ahead and get to cleaning up this board a little bit later, but for now I want to place the order on these 2200s, because those, like I said, I don't stock those. Okay, also while we're at it, we're gonna go ahead and check out this reverb tank. I want to make sure that the reverb tank is not the problem. Alright, so this is the input on this side. So I think if one of them was going to be bad, it would probably be this one, because I was hearing some I think I was hearing spring noise. Anyway, we'll check both ends. I was definitely hearing some noise at the output. From here to here. And that is open. It's open. This coil's open. Alright, well, a lot of the times when the coil's open, it's just a problem with the... can very often just be a problem with the broken lead. So let's gently lift this, and we'll play with the leads here a little bit and see if we can't get it to kind of close itself up. And actually, sometimes also if you hit the solder joint, you'll get a reading too. Oh, well, there we go. There's a reading. Okay. Okay, so it's not open. It's not, at least not this side of the tank. That transducer that coil's working. This one over here, let's check this side. Like I said, I can't remember whether I was hearing spring noise or not. I was definitely hearing some noise, but I can't remember if it was spring. And if it wasn't spring, this side's open too at the moment. Yeah, this side's showing open also. So let's do this. Try to clip that on where it'll stay. And we'll play around with these wires a little bit too and see if we can't get something to happen here. Let's watch this and we'll see if at any point this closes up. What can happen a lot of times is, oh, there it is. There's our problem. Let's see our problem with the reverb. I see it now. Like I said, I couldn't remember if I was hearing actual spring noise or if I was hearing just noise, but no spring noise because you see that wire right there. See that? See that green wire? It's come apart right there. There's a little tab, a little metal tab that bends over right there and kind of just holds the wires out of the way. You see that little metal tab? That tab right there obviously had, over time, just severed that wire. Yeah, I figured it was one or two issues, probably either the tank or that chip. I had experienced problems in the past with it being the chip on my Classic 50, but it looks like in this case it might, hopefully the chip is good. Okay, now for the messy part. We're gonna try to heat up all this adhesive and get this off of here. I'll bump it up to about 200. We'll go 220. I can definitely tell it's melting because I can see the cracks actually. Okay, watch over here. You see how this is all kind of cracked and how this is smooth? This over here was like this, but watch this. So it's definitely softening it up. Okay, see if we can get some of this off of here. Oh yeah, that's doing pretty good. Pretty much all of that adhesive off of that board. I'll probably take a little bit of lighter fluid and just kind of go over this, or alcohol or something, and just kind of go over this with a swab. Yeah, this is not really critical. This is just an extra touch to try to clean it up a little bit. I'm gonna put some new stuff on here on the new capacitors also. Yeah, I'm not gonna go overboard with it. That's good enough. Okay, so I have finally gotten the 2200 microfarad 50 volt caps in for this Classic 30, and we can finally finish this amp. I wanted to show you something, okay, on this amp. That's really a major flaw that we're gonna go ahead and fix while we have this thing. Most guitar amps on the outputs will have some kind of screen resistor for each one of the output tubes. We only have screen resistors on 2 of these tubes, and the other 2 are just direct from the screen supply. It's going to be kind of hard to read this as a printout, and it's not the greatest, I'll be honest, but what we're looking at here is those 2 screen resistors right here in this square, R43, this one, and then this one up here, R53. That's the other screen resistor. If we look at the board itself, we'll see those right here on the actual board. And you'll see, you know, there's one of them is leading to a jumper wire here that's jumping across to the tube socket board. But okay, so we've got these 2 resistors. If we follow the supply where it comes from, so we've got this line coming in here. Let's back up just a little bit so we might be able to see this a little bit better. Here we go. Okay, so right here at this point and this point, this is where the screen supply is coming in. We have a trace that's running under those 2 down through here and back this way, and it goes over this jumper wire right here to the next board where it's getting its supply. Okay, comes across this jumper, comes up here, supplies here, and then you know, you've got a resistance here over to this point, which feeds one of the tubes, and then you've got a resistance here again that feeds another one of the tubes. But we have this jumper that's coming across here, okay, and if we look at the boards, we'll see all of this. It jumps across to here and comes up here, and then there's another jumper right here. So we've got, first of all, we've got this jumper coming across to, the boards. Then we've got this jumper here that jumps over to this point, comes up here to pin 9, which is this screen, and you're looking at the top of the tube socket. You're looking at it from this orientation, from the top. But then it jumps across, you know, directly on this line over to this other tube over here. So this is how it's getting its feed. So what we're going to have to do here, first of all, we're going to have to separate this. We'll have to cut this trace right here. We'll have to separate this pin from this pin. Second of all, somewhere along the line back here, we're going to have to insert 2 new resistors. So you know, good points to do that probably would be on the other side of this jumper. Maybe taken off from, if we remove this jumper wire right here, we're going to remove this jumper. At least I think that's what we're going to do. Hang on, give me 1 sec. I'm pretty sure that's what I want to do. I will brainstorm on that a little bit, and I'll come back and I'll show you exactly what we end up doing, but that's what we're going to have to do to get, and then of course we're going to have to replace these with a higher value resistor, and we're going to put them, we'll probably make all of these resistors 1K, just depending on what I have most stocked. We could do 1K or 470. Either of those values will probably be fine, but we'll settle on one of those values and put those resistors in and swap out the ones that are already there. Okay, so there are all of the capacitors done. Let's go ahead and clip out these resistors, or we'll desolder them, whatever. Maybe I can use them in something else if I just desolder them. Probably easier just to clip them. Okay, I gave it some thought. I have a bunch more 680 ohm resistors than I do anything else, so I'm going to use 680 ohms, and it should be just fine. It shouldn't be any kind of problem there. Because we are going to a higher resistance, it's going to dissipate more heat. So that means the board's going to get a little bit hotter at this point. So I'm going to go ahead, I'm going to stand these up off the board I'm not going to flush mount them like this. I'm going to give them a little bit of breathing room on all sides, and on the bottom side I'm going to bend those legs over so they get a nice nice solid bite on the board itself, a physical connection. Okay, there's one down. Same thing here. I'm going to leave it some breathing room. Alright. So there are both of those soldered in, and they're, like I said, they're mounted up off the board. So even with the increased resistance, we shouldn't have any issues with heat. Okay, these right here, they only drop, they're only 3 ohms. So they're really not dropping a whole lot. They do get obviously somewhat hot because they've kind of cooked this board at this point right here, and I've got a good mind to change those and jump that up off the board to prevent that from cooking any further. But I don't have any 3 ohm resistors like that in stock, so that's going to be a no-go this time around. But I do see it, and it's something definitely to monitor into the future. We're going to have to mount these on the other side. They're not going to mount on this side. They're definitely going to have to mount over here. Well, obviously the first thing I want to do for sure is cut this trace. Okay, let's see. Okay, so we see this is V7, this is V6, this is V5, and this is V4, and we have the layout right here: V7, V6, V5, and V4. You can see the trace right here that we have to cut between pin 9 of V6 and pin 9 of V5. And we don't have as much light as we could have here on the desk because I forgot to turn one of my lights on, so sorry about that. It's gonna be hard to see because I'm gonna try to do this without bending this board too much. Proving to be slightly easier said than done. If I was doing it on accident, it would have been easy. It looks like I got it, but I'll test it in a second, make sure I got it. Test it with a multimeter. Okay, yeah, I definitely got it right there. Looks good to me, but we're gonna test it on the multimeter and make sure that it's not somehow still connected. Any connection at all. And we do not. Alright, good and severed. Okay, this part might be kind of hard to see. Once again, I'm sorry about this. If some of this is hard to see, it's just the nature of the thing. I can't really fix this the way they've got this thing built. So, first of all, let's go ahead and suck the solder out of the pin 9 right there. To recap what we have done here. So, we have replaced the 2 100 ohm resistors with 680 ohm resistors here. We've stood those up off the board a little bit, so there's a little bit of air flowing around them, and we made sure we bent the legs enough that they've got a good secure connection there. Okay, on this leg of this resistor right here, there's a jumper wire right beside it that jumps across over to here to this point. There's a trace that comes over to here. We have one of the resistors on the other side of the board going from this point right here. That's the resistor's leg coming through, and J hooking over here to this other resistor's leg. That resistor here is going over to pin 9 of this tube socket right here. Okay, you can see it on the other side there. That's where it's going. And then on this side we have the other resistors just going from here to here. So a pretty short distance, and you can see that one right there. So that's it. That takes care of the screen resistors. We now have all of the capacitors, the electrolytic capacitors that we're going to replace. They are all replaced. Now we're going to turn our attention to this wire on the reverb tank. This is very, very, very tiny wire. I'm going to try to capture this as best I can, but this is very difficult stuff to strip. I'm going to use these. These are the smallest strippers. I think these are capable of doing the smallest wire of anything that I've got. And I'm not even sure if they'll do it. You got to angle it just right on some of these sometimes. Yeah, you got to make sure too that you don't pull it out of the transducer over here. We'll squeeze from here to make sure we take the load off, and then that's how we'll strip that one. Gonna have to find the smallest bit of shrink tubing I have also to shrink tube that back. About half of a bit of that stuff. I think that'll work right there. And again, you sit here and work this back and forth, and before you know it, you're going to break the wire down here. So I mean, if you're doing something like this, just be very careful, you know. And grab it here like this to take the stress off, and then there we go. I'm going to go ahead and pre-tin these wires without burning them, because you can actually burn them very easily. And once you burn them, it's just the wire will just disappear. Basically, you've just burned it. There we go. They're there. That'll work. I think that's got it. Okay, so that's one repaired reverb tank, one repaired amp, and we're ready to get it back in the chassis and see what she does now. Okay, well here she is pretty much all back together. All I got to do is tighten these up and put the knobs back on, and we're pretty much there. And then we'll get the tubes back in it and see where we're at on bias and whatnot. Okay dudes, we're back with this Classic 30. It's up on the bench, it's all put back together, and we've got it hooked up for the moment to a speaker out here on the desk. You see it right there. And we're just gonna fire it up slowly on the Variac and just make sure we don't have any issues before we proceed any further. And let's get a cable so we can get a signal on the input. I just want to make sure we're getting something through the amp. Make sure all the tubes are lighting, all that kind of stuff. When when you've gone in and changed a bunch of stuff, that's usually advisable. But look at how you have to plug this. Look at how you have to lay this thing up on the desk to do any kind of troubleshooting to it. So I've got the transformers kind of are propping it up at the moment. I've actually got it too high. I didn't even need these. I was going to try to put it on these, but it won't balance. It wants to fall backwards. We'll just go slowly with it. We're at 32 volts in. There we've got light on the pilot at 82 volts in. We'll give it just a second here. That's probably plenty. We're at 85 volts. That should be about enough to start getting some kind of sound through it, and it is, and we have reverb. So our fix on the reverb tank worked. Both channels work. Okay, everything. Okay, so it's working fine. Now on to the biasing situation. I recently made a bias probe for EL 84s. I made this monstrosity, and we're gonna see if we can make this work. I don't know if the extra length being exposed is going to cause like oscillation issues in some amps possibly and stuff like that, but we're going to test it out right now. You're seeing it kind of firsthand. If you want to make one of these for yourself, I'll put up a video up here in a corner where you can go see that video. I'll post it separately. If it's not out at the moment, it will be soon. Okay, so we'll plug in our probe. Let's try it now. We've got our voltage meter set up here and our ammeter. So we'll go ahead and dial it on all the way up here and see what kind of readings we get. I'm hoping the battery in that flute holds out long enough. I don't think it's gonna. I don't think I'm gonna be able to read the voltage with this thing without changing batteries. Okay, we'll dial it on up to 120 volts on the input. But we're getting about 320 volts at the plate and 26 milliamps or thereabouts. So 0.026 times 321, 8.3 watts of plate dissipation. If the maximum plate dissipation is 12 watts, 12 times 0.7, that's 8.4, so we're right at about 70%. We could back that down a little bit by changing a resistor, playing with the value of a resistor in here, which we may do. We'll let that settle for a second. Try that one more time. 0.0254 times 322 skull and bones is 8.17. So actually I think we're looking fine right there. That's below the 70% mark. Could we dial it down? Yes, we could. But is it necessary to do that? It doesn't seem necessary to me. I don't think we're in any danger on these tubes. A lot of people will even run EL 84s much hotter than they're supposed to and get away with it, especially with some of the Softecs. I mean, they really run them to the limit. And I've argued with people online before. It's like you really shouldn't do that. But I've had people tell me, "Oh, on my builds, I run them at 100%, and they're still fine," kind of thing, and squeeze, you know, more wattage out of the amp. I don't see a purpose in doing that, but I think 70%, under 70%, this should be okay. I mean, 8 watts per tube at idle. I don't see any reason to go fiddling with that. I mean, could I install an adjustable bias pod and stuff and go all that distance in here? I could, but I just don't think it's going to be worth it in this case, because we're not, for this set of tubes, it doesn't appear as if we're going to get anything out of the deal. But I'll tell you what I will do. I will go ahead and move the probe to each one of these sockets, because I've only got one probe, so I'll just move it to each one of these sockets and make sure that there aren't any of these tubes that are out of spec or anything with the others, and we'll kind of go from there. Okay, I got this Classic 30 back in its cabinet, and it seems really stable and healthy. I'll show you what the tail of the tape looks like. So with 119 volts coming in, we've got 0.81 amps and about 83 watts of total dissipation on the entire amp. So that's about what a healthy Classic 30 should look like. So if you want to compare my numbers to your numbers, that will give you some basis for comparison. And now it's time to give this thing a test, and I think you're going to be quite surprised if you've never heard one of these Classic 30s. They are really a great sounding amp, despite the fact that they are built like a straw doghouse. I mean, it still is a good sounding amplifier, and definitely worth trying to fix if it's an easy fix. I mean, if it was too extensive or something like that, quite honestly, these are going to be garbage if one of the boards ever goes out on you. There is a good video out there by the YouTuber Brad's Guitar Garage. He's an Australian fella who did a video on these, a series. It's like a 2-part series. He went and like KiCad and made a board and sent it off and had it printed up and stuff, like a double-sided board for the tube board, and did some other things and moved the screen resistors down to that board, and it actually turned out really well. So it was a good job, a good thing that he did. If you have a Classic 30 and you have to replace that board, it might be worth contacting him to get one of those. Maybe he's got the KiCad documents or something. Maybe he can send you those and you can have your own board printed up. But, you know, other than that, man, honestly, these things will be garbage if they ever kind of go down. That's how poorly they're built. It's just, you know, these are a bean counter's wet dream, really, on the inside with the way they're put together. They're not meant for longevity. This is not a great amp in terms of build quality, but it is a great amp in terms of tone, and we're going to see that here in just a sec. Alright guys, that's going to do it for this one. I hope you've enjoyed this video on this Peavey Classic 30 from the mid-1990s, early 1990s. These came out, I think, for the first time in 1992, so 32 years old this year. There are a couple things that the customer had kind of asked for that I could not do. He wanted the internal speaker jack, which is way down inside of there, moved to the back panel, but you really don't need it. This extension speaker jack actually disables and bypasses the internal speaker jack, so you really don't need that one. Just use the external speaker jack right here that's already on the back panel. And plus, there's really no room because of the way that this is all laid out in here. There's no place to really put it. As for the reverb and making the reverb more saturated, I mean, I don't see any real need for that because it gets so saturated already that if you were to try to do that more, it would just really start to feed back and add a lot of noise. It's already a pretty noisy reverb circuit as it is. I don't know if it's the fault of the chip or what, but there's really not much else I could do for that. But anyway, did what I could for it. Hopefully the customer's satisfied. Hope you guys enjoyed this one. And if you have, hit subscribe down below. Also join me over on Locals if you want more behind the scenes stuff and just extra weird stuff. Also subscribe to my other channel, The Guitologist, where I do other kinds of stuff besides guitar related stuff. And yeah, that'll do it. And for now, we will see y'all later.